Okay, so let's look at part 2, forces in equilibrium. So forces in equilibrium means forces to the left equal to forces to the right, for example. That is equilibrium in horizontal. So horizontal resultant force is equal to 0. At the same time, we can also say forces that act upwards equal to forces that act downwards. In that case, vertical resultant force is equal to 0. So in this situation, right, there is no resultant force, or resultant force equal to 0. And because of that, we can say that it is in equilibrium. Okay, now let's see number 2 here. The triangle of forces, when there are only 3 non-parallel forces acting and they are in equilibrium, the polygon of forces become a closed triangle as shown for the break on the plane. So again, you can see this. We have an inclined plane again. So inclined plane. So the weight is here, okay, mg. That means, this is 3 times g. This is mg. The normal reaction is acting here, R. Okay, and then the frictional force is acting opposing the motions. So if let's say this brake is in equilibrium, then we can take 3 of these forces, join them up in this particular way. You can see here, downward is the weight, this is the frictional force. You see that join up, going down, then continue with frictional force, then continue with the normal reaction. So joining up, and you always manage to form a closed triangle, to form a closed polygon in general. So for 3 forces, they form triangle. For more than 3, of course, they form other polygons. But it is always a closed polygon if they are equilibrium. Okay, so then number 3, we have Lamins Theorem. State that when 3 forces acting at a point, something like this, acting at a point, as shown in the diagram, are in equilibrium, then F1 over sine alpha, you can see F1 over sine alpha, F2 over sine beta, F2 over sine beta is this force divided by sine beta, then F3 divided by sine gamma. So F3 divided by sine gamma. So this is Lemma Theorem. In order to understand Lemma Theorem, right, so I will just explain a little bit by using some mathematical knowledge that we learned before, so that is easier for you. So I will start with the easier one, F1, which act downward. Okay, so followed by, what am I trying to do is, I'm trying to do something like this. You have 3 separated, 3 non-parallel forces that act on the objects. So I'm going to form the closed triangle. Okay, so now I have drawn out F1. So now let's say I draw F3 first. Okay, I draw F3 first. You are free to decide after F1 you want to join with F2 or F3, it's up to you. So in order to make it easier, so I draw F3 first, then followed by F2. So like what I said, they always form a closed triangle. So we have F1, F3, and F2 join up already. Okay, so let's put in the angle. The first one is alpha. Alpha is between F2 and F3. So if I make my F3 longer a little bit, so as you can see here, if I make it longer a little bit with dotted line, so alpha is supposed to be here. That is alpha. Now let's look at beta. So where is beta? Beta is in between f3 and f1. f3 and f1. So if I make my f3 longer a little bit, as you can see here, so f3 is longer a little bit, and now beta is there. Okay, beta is there. Huh? So as you can see here, beta is here. Now how about gamma? Gamma is in between f3 and f1. F2 and f1. So in between f2 and f1, okay, so I need to make the line longer a little bit also. And then gamma is there. Okay, so this is gamma. So all the angles are angles outside of the triangle. So in order to get the angle inside the triangle, I have to use 180 minus. So for example, this angle is 180 minus alpha. The angle up there is 180 minus gamma. The angle down here is 180 minus beta. So after doing so, I apply sine rule that we learned in mathematics. So if we use sine rule, it is going to be, I hope you remember sine rule. So you take f1 divide by the sine of the opposite angle. So you will get f1 over sine 180 minus alpha. Okay, then is equal to f2 over sine. Opposite angle of f2 is 180 minus beta. And then you will also get f3 over the opposite angle. So f3 over sine 180 minus gamma. So based on sine rule, you get something like this. And you have to know your trigonometry formula, saying that 180 minus x is actually equal to sine x. Okay, so that's the formula. And if you apply it here, then you will get the Lamins Theorem already. So Lamins Theorem is basically sine rule with some extra extension. Okay, so yeah, Lemma Theorem. So by using one trigo formula like this, and then you get Lemma Theorem. So Lemma Theorem is a fast way for you to form something like sine rule, where f1 straight away divide by the sine of this angle at the other side of the two forces. Okay, so then f2 divided by sine beta, which is at the other side of the force, or in between of the other two forces. F3 divided by sine gamma. Gamma is the angle between the other two forces. Okay, so that is Lemma Theorem, which is actually sine rule. Okay, so now this part settled already. So we just move on. Forces in equilibrium. Let's see one. Okay, so let us look at these questions. This question is about forces in equilibrium. So let's go through. A light inextensible string. Light inextensible string means mass equal to 0. So when you consider weight, right, you can just ignore the weight of the string. No mass for the string. Okay. Inextensible means you're not going to use Hooke's law and all those. So we can just do it without caring much about the string. The string create tension. You have to care about that only. Other than that, the rest don't care. Okay, so has its ends attached to two fixed points A and B. So you can see the string attached here and here, with A vertically above B. So A vertically above B. So like this, you can see that. A smooth ring R So when they say smooth ring R, that means no frictions happens. No friction here. Yeah, that's a smooth ring of mass 0.8 kg. 0.8 kg. So I change it to weight first. So, again, W equal to mg. W equal to mg. So 0.8 times 10 equal to 8 Newton. So the force that acts downwards due to the weight is W equal to 8 Newton. Okay, now let's move on. Is threaded on the string and is pulled by a horizontal force of magnitude x Newton, as you can see, x Newton to the right. The section AR and BR, so AR, BR of the string makes angle 50 degree. So you can see that 50 and 20 degree respectively with the horizontal as shown in the diagram. The ring rests in equilibrium. So we apply equilibrium concept. The ring rests in equilibrium. So we assume the ring remains stationary here. Remains stationary. Okay? With the string taut. Taut means the string are in straight. Straight. Not like if it's not taut, then the string is bending. So it's bending, not straight. So it's in taut. That means straight. So that means there are tension. Yeah, there are tension. So there are tension acting. Maybe I can just draw out first. There are tension acting here, here, and here. Okay, there are tension of the string. Okay, so now find the tension in the string. Find the tension in the string. Okay, so oh yeah, by the way, this is not part of the string. So I have to erase the tension over there. The string is actually, okay, I put in red color. The string is here to here. So the red line that I draw is the string. Okay, the string. The string is fixed over here at point A, and the string is fixed at point B and passes through the ring, and then you pull the ring to the right, and then the string are in taut. Okay, so the tensions of the string is here and here. Okay, so that is the tension of the string. So what to do is, in part 1, we want to find the tension in the string. So based on the idea of equilibrium, right? So we have to resolve the forces into horizontal components, and then you just say forces to the left equal to forces to the right. So you also need to resolve it to vertical components. Then after that, you use equilibrium concept and saying that forces acting upwards equal to forces acting downwards. So we start with horizontal component. Horizontal component, you can just draw an arrow in horizontal. The examiner will understand this is horizontal component. Okay, so now we have to resolve. Yeah, we have to resolve. So to resolve, we have to build a right angle triangle. This is the first one. Okay, so the directions of the components. When you set up the direction of the component, make sure you follow the force. If the force is acting this way, right, so then it's like going that way also. The component is going that way also. Okay, through two components. Okay, so have to go to the same directions. Now, in order to find out the component, right, so this one is going to be the opposite u sine, so this is the adjacent of 50 degree. So adjacent, you use cos. So this is going to be t cos 50. This is going to be t sine 50. Okay, so likewise, we can also resolve this triangle down and left. Okay, so for this one, this is opposite. So opposite is sine. So t sine 20 degree. And the other one, this one is adjacent. Adjacent to 20 degree. So that's why this is cos. T cos 20 degree. Okay, so now let's gather up all the horizontal components. Horizontal components, I circle up in green color, let's say, so that you can see horizontal component. So we have t cos 50, and we have t cos 20, this is horizontal also. We have x Newton, this is horizontal. So three of these are in horizontal. So since they are in equilibrium, what we can say is forces to the left equal to forces to the right. So we can form an equation. T cos 50 degree plus T cos 20 degree equal to forces to the right, which is x. So we get this equation now. Now, for vertical components, we can also form equation accordingly. So let's say I circle out all the vertical components. So we have, I circle it in yellow. So we have t sine 50 degree, t sine 20 degree, and then 8 Newton. So these three are the forces that act vertically. So we can form an equation also. So since they are equilibrium, we just form our equation by using the concept of forces acting upwards equal to forces acting downwards. So forces acting, the only force that act upwards is t sine 50 degree. So there are two forces that act downwards, which are t sine 20 and 8 Newton. Okay, so we form the equation already. So what to do is we just need to work it out and find t. So to work it out and find t, the vertical component is good enough already. Okay, the vertical component. The horizontal component, there are two unknown. There are t and x that we can't solve. So the vertical component we can just solve and find t. Okay, so let's continue with the vertical component. Okay, so what we can do here is just some algebra. T sine 50 minus t sine 20 equal to 8. Factorize the t. Sine 50 minus sine 20 equal to 8. So you get t. Sine 50 minus sine 20. Then you press calculator, and at the end you will get 18.9 Newton. Okay, so that is the tension in the string. Now they ask you to find the value of x. So finding value of x is not too hard actually. You just need to make use of this horizontal component, this equation. The x is there. You substitute t with your result, 18.9. So 18.9 cos 50 plus 18.9 cos 20 equal to x. So x equal to 29.9 Newton. Okay, so just like that. Okay, so the calculation is kind of simple, but resolving it, make sure you don't make mistake. So resolving it is very critical here. So if you know how to resolve the component of forces easily, then forming equation should not be a problem already. So this one settled already.